This is section 11.2, Arithmetic Sequences in Series. This slide shows you the objectives for this section, and basically arithmetic sequences is just a specific type of sequence. So we're going to spend this lesson looking at those types of sequences in depth. An arithmetic sequence is basically a sequence that is composed of terms that differ by a specific number, and that number is the common difference. The common difference is going to be represented by the letter D, or the variable D, and that common difference is found by taking, for example, the second term minus the first term. And that value should be the same number as the third term minus the second term, or the fourth term minus the third term, so on and so forth. So let's begin by determining whether or not these are arithmetic sequences, and if they are, identify the common difference. So what I'm going to do is I'm going to begin in this first example by taking the second term minus the first term. So 3 minus 1, that's 2. Okay, now I'm going to take the third term minus the second term, or 9 minus 3. Well, that is 6. Because these values are not equal, no, this is not an arithmetic sequence. Let's do the same thing in the other example. I'm going to take the second term minus the first term, or 9 minus 4 in this case, which is 5. I'm going to take the third term minus the second term, which is 14 minus 9. Well, this is also 5, so we're off to a good start. I'm going to take the fourth term minus the third term, or 19 minus 4. This is also 5. As I proceed, I can see that all of these differences are 5. So, yes, it is an arithmetic sequence, and the common difference is 5. Okay, so moving right along, now what we want to do is we want to write the first 4 terms of the sequence. And I'm telling you that the first term is negative 2. So that means a sub 1 is negative 2. I've also told you that the common difference is negative 3. So in order to find the second term, I'm going to take the first term and I'm going to add a negative 3 in this case. This gives me a negative 5. To find the third term, I'm going to take the term before it, which is negative 5, and I'm going to add the common difference, which is negative 3. This gives me negative 8. I'm going to take the term before, which is negative 8, and add the common difference. So all I have done here to find the first 4 terms of this arithmetic sequence, I've taken the term before it, and I've added in the common difference. So this created an arithmetic sequence. Sometimes I'm going to want to find a specific term in the sequence. Maybe I want to find the 7th term, for example. If I want to find the 7th term of an arithmetic sequence, I can simply use this formula here, where I take the first term of the sequence times n minus 1, which would be 6 if I'm interested in the 7th term, and then I would multiply by the common difference. Let's look at an example. Now, in this example, I want to find the 23rd term of this arithmetic sequence. And you know, I could go ahead and find the common difference and then do that 23 times, but that's not an effective use of my time. So the first thing I'm going to do is write down the formula, and that is a sub n is equal to a sub 1 plus n, the quantity n minus 1 times d. Now I know the first term already, and if I want to find the 23rd term, that means n is 23. So the only thing I need to do is find d. Okay, well, we already know how to find d, and what I can do is I can take the second term minus the first term. So this is 5. So what that means is if I add 5, add 5, add 5, if I keep doing that, that will give me all of the terms of the arithmetic sequence. So let's plug in everything we know. A sub 23 is equal to the first term, which is negative 8, plus n is 23, because that's the 23rd term, minus 1 times 5. So simplifying all of this, I should get 102. So the 23rd term of this sequence is 102. Now, this is the same type of problem, but slightly different information is given to us. Now we want to find the 40th term, and we are specifically told the first term and the 11th term. So what we want to do here is we still need to find d, but let's piece together all of this information we're given. We are given that the first term is 12, and that a sub 11 is negative 38. So when n is 11, so the 11th term is negative 38. Okay, well, recall that the formula we use is this one here. Well, I have everything I need in order to find the common difference. So let's plug that in. This is negative 38. This is 12. And we already said n is 11, leaving us with only one variable of d. Okay, well, solving this, negative 38 is equal to 12 plus 10d. If I subtract 12 from both sides, I get negative 50 is equal to 10d. So negative 5 is d. And just so you know, the common difference is not always 5 or a multiple of 5. Okay, so now that we have d, I can go ahead and find the 40th term. So a sub 40 is equal to, it's still the first term, that's still 12, plus, since I want to find the 40th term, that means n is 40, so this is 39 times d. Oops, but remember d is negative 5, which we just found. When I multiply this out and add 12, I end up finding that the 40th term is negative 183. Okay, so of course we're going to have some application problems. So we know that we are going to have to use this formula, so I'm just going to jot it down. The more you write it down, the more you will remember it. So go ahead and pause this and read through this example. So here we have a monthly record of electric bills, and we want to know if this follows an arithmetic progression. Well, what we can do is find the difference in each of these. So for part A, if I find the difference between this, I get 5.4. The difference between the second and third year is also 5.4. And the fourth and third is also 5.4. 5.4. So I can see that there is a common difference, and that common difference is 5.4. So yes, it does follow an arithmetic progression. All right, so for part B, write an expression for the nth term. Well, this is the common difference, so this is D. We know the first term, so a sub 1 is this. So we have everything we need to write an expression. So we can say a sub n is equal to, the first term is 102.60 plus the quantity n minus 1 times d, which is 5.4. All right, moving right along to part C. It says predict the average monthly bill for year 6 if this trend continues. Well, yes, we could easily add 5.4, and boom, we would be there. But let's go ahead and show this using the formula. If I want to find the bill for the 6th year, that means n is 6. So I'd have 102.60 plus 6 minus 1. This just becomes 5 times 5.4. Go ahead, plug this into your calculator, and you will find that we end up with $129.60. When the number is so close to the numbers we are already working with, it does make sense to just add 5.4 twice. But suppose I want to find the average monthly bill for year 20. Well, in that case, it would be much more efficient to use the formula. Okay, now this is an example that's different than what we've seen before, but we're still going to use that same formula to help us answer the question. We're just going to use it a little bit differently. So now we want to find the number of terms of this finite arithmetic sequence. So what we want to do is we want to find n in our formula. Okay, well, looking at this, since it's an arithmetic sequence, we know that we are going to use this formula. And later in the chapter, you'll find that we have lots of formulas, so make sure you start making a list of the different formulas we're using. Okay, so what we can see here is several terms. We can see the first term, which is helpful. We can also see the second term. That's nice. That helps us find D. So again, we find that the common difference is 5. I suppose I didn't do a good job making these examples. But we can also use this last term here. And if we use this last term, then all we need to do is find n, which is ultimately our question. So we know our last term is 98. That is the value of the last term, but we don't know the number of terms it is. So we'll have 98 is equal to 3 plus n minus 1 times 5. I could go ahead and distribute this. So I'll have 98 is equal to 3 plus 5n minus 5. Combine like terms. And then we would have 98 is equal to 5n minus 2. Then I'll add 2 to both sides. And I have 100 is equal to 5n. Divide by 5, and 20 is equal to n. This means that there are 20 terms in this sequence. And the 20th term has a value of 98. Okay, so here is another type of example, and this one is similar yet slightly different. Now we've been told the value of the 11th term and the value of the 25th term. And our goal in this problem is to find the 400th term. So I don't know about you, but I'm pretty busy and I don't have time to actually calculate all 400 terms. Yeah, I could make a sweet spreadsheet that can calculate it for me, or I can use this fancy formula. Isn't that wonderful? So what we're going to do is we're going to set up a system of equations. And this system of equations is going to help us find the common difference and the first term, because we need the common difference and the first term in order to find our 400th term. So, same formula that we've been using. Hopefully you have this memorized by now. Okay. So we're going to plug this information into the formula. So the 11th term is 65. We do not know the first term, but in this case we're dealing with term 11. And we don't know the common difference. I can go ahead and simplify this a little bit. So I have 65 is equal to the first term plus 10d. Now I'm going to take this information and plug it into the same formula. The 25th term has a value of 149. We still don't know the first term. This is 25 minus 1 times d. Cleaning this up, I have 149 is equal to the first term plus 24d. Okay, so hopefully you can recognize that this becomes a system of equations. So we want to solve this by substitution or elimination. In this case, I would choose to do elimination by multiplying this by -1. When I multiply that first equation by -1 and I add it to the second equation, I end up getting 84 is equal to, these will cancel out, 24d minus 10d gives me 14d. I'll divide both sides by 14, and I'm able to find the common difference to be 6, something other than 5 in this case. Great. Okay, now once you have d, remember when you solve a system of equations, you go back to one of these two equations, plug in what you found to find the other missing variable. So in this case, 65 is equal to, I still don't know the first term, but I do know d is 6. So I'm just plugging this in to this first equation here. So I'm going to subtract 60 from both sides, and it seems I cannot get away from the value of 5. My first term is 5. Now I have everything I need in order to find the 400th term. So to find the 400th term, I've found the first term to be 5. 400 minus 1 times the common difference, which is 6. So this is 399 times 6 plus 5 gives me a value of 2,399 for my 400th term. Let's take a look at another real-life example. So Edward has a savings plan, and it's a very minimal savings plan, as you can see, because he is putting 1 dime in this piggy bank to start with. Then each week he is going to add a quarter. And what we want to do first is just write an equation that represents the nth term. Okay, so this is just a very basic equation. All right, so let's write down the things we know. We know he is starting his plan by putting in a dime. And I'm going to use whole numbers instead of decimals to represent the numerical value. So on day one, on the first week, he is starting with a value of 10 cents. So the first term is 10. And then after that, he is putting in 25 cents, 25 cents, 25 cents, 25 cents, which means my common difference is 25. So if I were to write my basic equation, I would say A sub n is equal to the first term plus n minus 1 times d, and in this case d is 25. Now it's perfectly acceptable to leave this as your answer, but you will find that sometimes the textbook will simplify this, so they'll distribute the 25 to get 25n minus 25. And then they'll combine like terms here to end up with A sub n is equal to 25n minus 15. So they might use this as the equation to find the nth term. Either way is perfectly fine. I will accept either of these. Okay, so we have answered this first part of the question. Now the second part says, how much money will Edward save in a year? Well, that's a little tricky because we only know the amount that he is putting in each week. So we need to convert weeks to years. Well, at this point in your life, you should know that there are 52 weeks in a year. If not, don't tell anyone. Shh, now you know. So that means n is 52. So I want to find A sub 52. And you can plug that into either equation for n. So 25 times 52 minus 15 will give us 1,285. Now this is where you need to be a little cautious of your work. That doesn't mean he's going to have $1,285. Remember from the beginning, this is a very minimal savings plan. So we will want to divide this by 100, and we will find that in reality, Edward has saved a whopping $12.85. Now we're moving on to something a little different, and that is identifying a partial sum of an arithmetic sequence. So we have found the first n terms, but sometimes we may want to find the sum of those. And we can do that easily by applying this formula. And n is still the nth term, and a sub 1 is still the first term. So here is yet another formula you should add to your list, and this represents the sum of the first n terms of an arithmetic sequence. Let's look at some examples. So here it says find the sum of the first 25 terms of the sequence. Now you can see here I only have the first 4 terms, so I don't even know what the 25 terms are. So it's helpful to refer to the formula. So the sum formula is S sub n is equal to n divided by 2 times a sub 1 plus a sub n. Now looking at this, I know that n is 25. I know my first term is 3, but I have no idea what the 25th term is. So I have to use the information I learned earlier in this video or in the section first in order to identify what a sub n is. So I need to find a sub n using the previous material, and then I can go ahead and find the sum. Okay, so first, find the nth term. Okay, well, we know the first term. We can find d, or the common difference, by taking 7 minus 3. That gives us 4. So recall our formula is this. Plug in what we know. So we're looking for that nth term. The first term is 3. N is 25. Minus 1 times d, which is 4. So I have 3 plus 24 times 4. This gives me 99. So if I were to write down all of these terms, the 25th term would be 99. Great. Now we have all the information we need to find the sum. So we're going to use this formula. So S sub n, or in this case S sub 25, this represents the sum of the first 25 terms, is equal to 25 divided by 2 times the quantity 3 plus 99. So 25 divided by 2 times 102 gives us 1,275. And what this means is if I were to add all of these 25 terms together, I would get this value. Same problem, different look. So we want to find the sum. We're using the summation notation, which is perfectly fine. So remember, to find the first n terms of an arithmetic sequence, this is the formula we need. So I know n is 22. So I have this piece. I want to find S sub 22. I know this is 22. But what I don't know is the first term and the 22nd term, or the last term. So that's what I need to find. So my first term is found, since k is 1, I'm just going to plug in 1. So 8 minus 5 times 1. 8 minus 5 is 3. So my first term is 3. Okay, now I need to find the last term, which in this case is the 22nd term. So I'm just going to plug 22 in here for k. So 8 minus 5 times 22. This gives me negative 102. So the nth term is negative 102. So I have everything I need here. Plugging this in, I can simplify this in my calculator if needed. I should find that the sum of the first 22 terms of this sequence is negative 1,089. And that's the final answer. See if you can try this one on your own. Okay, so I need to find the first term and the last term, which is going to be 80 in this case. So the first term is found by taking 4 times 1 plus 3. That gives me 7. The last term is found by taking 4 times 80 plus 3. That is 323. Into my formula, I take n divided by 2, in this case 80 divided by 2, times the first term, which is 7, plus the last term, 323. This gives me 40 times 330, which results in 13,200. So the sum of the first 80 terms of this arithmetic sequence is 13,200. Here is a real-life example of when arithmetic sequences can be used. I think it's kind of neat how it can be used in this case. Go ahead and pause this and read through this example. We're talking about an amphitheater here with rows of seats, and as the rows get bigger, there are more seats. And I know this is an arithmetic sequence because if you list the sequence, the first row has 11 seats, the second row 16, then 21, and so on. And so we want to know if there are 24 rows, how many seats are in the last row. So basically, if this is n equals 1, n equals 2, n equals 3, this is row 1, row 2, row 3, row 24, how many seats are in it? So we want to find the value of the last term. Okay, so we're not finding a sum here. We just want to find the number of seats. Okay, so we know the first term is 11. We can find the common difference easily by taking the second term minus the first term, giving us 5. Oh, surprise. Okay, so our formula then is the first term plus n minus 1 times 5. If you want, you can go ahead and write this, like simplify it. So this would be a sub n is equal to 11, oops, it would be 5n plus 6. So you can use this formula or this one. It doesn't matter to me. But we know n is 24, so we want to find a sub 24. So 5 times 24 plus 6. This gives us 126. So this means there are 126 seats in the last row, or in that 24th row. You can also find the total number of seats in the amphitheater by using that sum formula that we learned a little bit ago. Let's take a look at one last example. Here, Donna is given 2 different job offers, which is great, good for Donna. The first job pays $60,000 for the first year, and then Donna is lucky to get a $2,500 raise each year after that. The second job pays $50,000 a year with a raise of $3,000 for each year. So what we want to do is we want to find out if Donna plans to stay at the same job for 20 years, we're talking longevity here, which job would be the best offer? And would that be the same job if she were to stay for 30 years? Okay, so we're going to analyze which job would be best for 20 years, which job would be best for 30 years, and if it is the same thing. Okay, so I'm going to take this information and solve it on the next slide. Okay, so let's start with 20 years. She has the first job offer. And in the first job offer, we know that she is paid $60,000 for that first year. So that means the first term is $60,000. And then after that, every year after that, she is paid $25,000 $2,500 more, which means the common difference is $2,500. So we want to find the amount she makes in 20 years, or the amount she makes in year 20. So the 20th term is found by taking 60,000, which is the first term, plus n minus 1, or 20 minus 1, which is 19, times the common difference of 2,500. This results in a value of $107,500. Okay, well, let's compare that to the second job. Now, we saw in the previous slide that the second job is going to pay a little bit less that first year. So that first year that Donna is there, she gets $50,000. But then every year after that, she gets more. She gets $3,000 each year. So if I want to calculate the amount of money she will be earning in her 20th year, or A sub 20, I'll take the first term plus, again, n minus 1, which is 19 in this case, times the common difference, which is different than the first job of 3,000. When I calculate this, I get 107,000 even. So looking at this, even though it's not a lot, the first job would pay more the 20th year. So this one would be the better choice. Now let's go ahead and analyze the same thing, but after 30 years, and we'll see if it's the same thing. So 30 years, job 1, same formula as before. So we're starting off with $60,000 that first year. Oops, plus. But now n minus 1 is going to be 29 because 30 minus 1 is 29. And she is still getting $2,500 each year she's there. Plugging this into the calculator, she should be making $132,500 in that 30th year. Okay, well, let's compare that to job 2 on year 30. She starts off with a salary of $50,000. 29 times the common difference of 3,000. When I plug this into my calculator, I get $137,000, which is quite a big difference compared to the first job. So now, between 20 and 30 years, you can see quite a big jump in her pay. So job 2 would be better if she can look into the future 30 years. This concludes the section.